All right, let's take a look at this nice one from section 9.1, number 6. We're going to find the general solution of this differential equation using separation of variables as we've learned about in this section. And note the comment in there. I didn't completely write out the same thing, but they talk about fraction form. Okay, so you have to have your final answer in a fraction form, exact value in fraction form, and absorbing into C as much as possible. Okay, and so there's a particular way they want that done, and let's show how that comes out. So the first thing is I would rewrite y prime as dy dx, and I would subtract the 6y squared to get to here. Now if I multiply by dx, I have this. And then I want to get the y's over here with the dy and the x's over here with the dx. So I'm going to divide by x to the sixth and divide by y squared, both sides. And when I do that, I get to here. Now I'm all set up, right? I've got this set up to integrate. I'm going to integrate both sides of this equation. And what do I get when I do so? Well, notice I'm going to rewrite 1 divided by y squared as y to the negative 2 because this is power rule here. And similarly, 1 over x to the 6 is x to the negative 6. That's power rule. Okay. Antiderivative y to the negative 2, add 1 to negative 2 is negative 1. I get y to the negative 1 divided by negative 1. Over here, I got negative 6 as a constant multiple. Add 1 to negative 6 is negative 5. And so there's my antiderivative. Don't forget your plus c. You've got to do it at this point right now. So if I clean this up a little bit, notice a negative times a negative is a positive, or divided by a negative is a positive. And this x to the negative fifth comes down as x to the positive 5, right? 6 over 5 x to the fifth. Y to the negative 1 is 1 over y, and it's negative 1 over y. Now, before I solve for y, I'm going to, right, because you can multiply both sides by negative 1 at this point. That's fine. You could do that. But I'm going to go ahead and notice, excuse me, that I'm going to be solving for y here. So I'm just going to take the reciprocal of both sides. And if I take the reciprocal of this as is, it's going to be a compound fraction, right? It'll be 1 over all of this stuff. Don't forget that 1 over y, or negative 1 over y, equals this stuff plus the c, right? This is all on this side of the equation, right? And so we would invert this whole thing. And so it's much better because they want it in a fraction form. And by that, they don't want a compound fraction. So I'm going to write this as one fraction by simply adding. And what do I need? I need a common denominator. I mean, literally, this is c over 1 if you want to think about it that way. But I can write this over 5x to the fifth by multiplying top and bottom by 5x to the fifth. And then I can combine, right? Now, I will note that when I do 5 times c here, I'm going to write that as just another constant because we're instructed to absorb into c as much as possible. That's what they mean by that, right? So I don't want to write this as 5c x to the fifth. I just want to write 5 times c will be some constant. Again, I'm writing c here. These c's are not the same. In fact, this blue c here is obviously 5 times the green c, okay? So if the green C were 3, then this blue C would be 15. Okay, so I've got 6 plus cx to the fifth, right, divided by the common denominator. And now I can multiply by this negative 1, which becomes negative times this fraction. And now when I take the reciprocal of this side, I just take the reciprocal here, and I get to this solution. So here is a fraction form absorbing into C as much as possible. Okay, kind of a tricky one, but interesting. I hope you like that.